Alright, lesson 4.6 is about congruence in right triangles, and our objective is to prove triangles congruent using the hypotenuse leg theorem. So first, let's start with vocabulary and key concepts and look at what the hypotenuse leg theorem says. This theorem says, if the hypotenuse and the leg of one right triangle are congruent to the hypotenuse and the leg of another right triangle, then the triangles are congruent. And they didn't have a picture for this one, but I'm going to draw one just for reference. It's not going to be the best because I'm not a great artist, but we'll go with it. Okay, I've got two right triangles, A, B, C, and E, F, G. Okay, what this is saying is if one of these legs, so let's say this side AB is congruent to EF, and the hypotenuse AC is congruent to EG, then the whole triangle is congruent to each triangle is congruent to each other. So ABC is congruent to triangle EFG, since they have a hypotenuse and a leg that are congruent. Okay, so it's important to know what the hypotenuse is. So the hypotenuse of a right triangle is opposite the right angle so it never really touches the right angle because it's opposite the right angle. And I think this makes it easier to identify. It's always the longest side. That makes it really easy to remember which one is the hypotenuse. It's the longest side. The legs of the right triangle are the two sides that form the right angle. So in this picture down here, this long slanted side would be the hypotenuse, and these two sides over here that make the right angle would be the legs. Okay, so knowing that, let's jump into some examples. The first example is proving triangles congruent. One student wrote triangle CPA is congruent to triangle MPA by the hypotenuse leg theorem. Is the student correct? So we know CA is congruent to MA because they're marked right here. That's given. We also know angle CPA is congruent to angle MPA because they're both 90-degree angles. And we know PA is congruent to PA. That's this line in the middle that's part of both triangles. So then, since AC is the hypotenuse and PA is a leg of right triangle CPA, and MA is the hypotenuse, and PA is a leg of right triangle MPA, the triangles are congruent by the hypotenuse leg theorem. So the student is correct. So all we did was notice that the hypotenuse was congruent to the hypotenuse. We know that each triangle uses this leg, so it has to be congruent to itself. So we know that the two triangles are congruent by the hypotenuse leg theorem. Okay, number 2 is a flow proof. We know triangle XYZ is isosceles. From vertex X, a perpendicular is drawn to YZ, intersecting YZ at point M. Explain why the triangles are congruent. So, line XM is perpendicular to line YZ. This was given. They told us they drew it perpendicular. Angle XMY, so this angle, and angle XMZ are right angles by the definition of perpendicular lines. Remember, perpendicular lines always intersect at a 90-degree angle. So since XM is perpendicular to YZ, those have to be 90 degrees. So then we know that the triangle XMY and XMZ are right triangles by the definition of a right triangle. Each of them has one 90-degree angle. That makes it a right triangle. Okay, so then side XY is congruent to side XZ by the definition of an isosceles triangle. Remember back up here, they told us this big triangle is isosceles, so we know that it has to have two congruent sides. Then we know XM is congruent to XM, this side in the middle on both triangles, by the reflexive property of congruence. So, using those facts, we know that each triangle is a right triangle. We know XM is congruent to XM, so that would be a leg of each triangle. We know the hypotenuse of each right triangle is congruent to each other, so triangle XMY is congruent to triangle XMZ by the hypotenuse leg theorem. All right, let's keep going with this. So, two-column proof using the hypotenuse leg theorem. Angle ABC and angle DCB, so ABC and DCB, are right angles. And that was given to us right here. Triangle ABC and triangle DCB are right triangles by the definition of a right triangle. So as soon as we know the triangle has one right angle, we can say it's a right triangle by the definition of a right triangle. We know that AC is congruent to DB. They gave us that right here. And that's given. So I know AC, this side here, is congruent to DB. Well, that'd be the hypotenuse of each of those triangles. So then I need to prove a leg. Well, they both share this side, CB. So CB is congruent to side CB by the reflexive property of congruence. And then we know that triangle ABC is congruent to triangle DCB. We're going to make a couple notes here. So AC is the hypotenuse of triangle ABC. DB is the hypotenuse of triangle DCB. And side CB is a leg of both ABC and DCB. So therefore, triangle ABC congruent to triangle DCB by the hypotenuse leg theorem. Okay, so we just said we proved the two hypotenuses congruent. We proved that two of the legs are congruent. So that's why we could use the hypotenuse leg theorem to prove that. Okay, there are a couple Check for Understanding questions to do today. The first one I think is relatively easy. If you look at the triangles, you're supposed to pick which two triangles are congruent by the hypotenuse leg theorem. So one of them is not. So hint, the hypotenuse leg theorem means you have to have an hypotenuse and a leg marked. Number 2, you're going to write a paragraph proof of example 2. So that was the flow proof that we looked at. So all you're going to do is put this into words. So you could say, it is given that XM is perpendicular to YZ, and triangle XYZ is isosceles. Since line XM is perpendicular to line YZ, angle XYM and XMY and XMZ are right angles. And you just keep going, follow the arrows, just make sentences out of what's written there. And then number 3, you know that 2 legs of one right triangle are congruent to 2 legs of another. Explain how you prove the triangles are congruent. So, let's try that again. If I know that I've got two right triangles, I did not draw these very well, but I know the 2 legs are congruent. How can I prove these are congruent? And you're not going to use the hypotenuse leg theorem. You're going to use one of the previous theorems that we have learned to prove that. And I think if you look at the sides and the angles, that should help a lot. Okay, go ahead and get started on those. If you have any questions, I'm here for you, and good luck.